Well, hello friends. Welcome back to browser hacking. Today we are going to do more performance work on the Serenity OS browser, and I'd like to continue investigating kind of the same stuff we did last time, which was hovering over different elements on GitHub and profiling and optimizing to make the CSS hover effects go faster, because I think there's a lot of money on the table here, stuff we can improve. And I already have some ideas, but let's get started with just grabbing a profile. So last time we were just hovering over these links here to different files. And let's grab a profile of doing that, because as you can see, it is pretty laggy when I do that. Like the links don't get underlined right away. And that's enough of that. So let's take a look at what our web content process is doing. I've done a bit of work since last time. So on style invalidation in particular. But if you watched the last video, then you'll recognize the stuff at the top here. We have selector matching and just collecting all of the matching rules for every element, stuff like that. But if we turn the profile upside down and use the top functions mode, we can see sort of a flipped view of what's happening in the program. And one thing we have going on here is layout tree building. So about 35% or so of CPU time while I'm hovering like a madman is spent building the layout tree. And I think we can stop doing that, but it's going to require a bunch of work. So basically what the layout tree is, if you're not familiar, so in a browser you have a DOM tree, right? This is the tree that you make with HTML, and then you can also mutate it from JavaScript, but it has your basic HTML elements, text nodes, stuff like that. This is the DOM tree, the document object model tree. But it's not really suitable for rendering, right? Like, because what if you put CSS that says display none on one of your elements, then you don't want to render that element. So what we do is we take the DOM tree and then we combine that with CSS to produce a layout tree. And then the layout tree is essentially the tree that we size and position to create what you see on screen. And then in the Serenity OS web engine in libweb, we also have a third tree called the paint tree, which is relatively new, that comes after the layout tree. So the DOM tree plus CSS becomes the layout tree. And then the layout tree is sized and positioned, and that in turn becomes the paint tree, which we can then use to paint on screen. Anyway, something that's important to note here is that when I'm hovering over these things, whenever style changes on the page, we will currently recompute style for every element, and we will relay out the page. But if you look at what's actually happening, you'll see that the color of the text changes, right? It goes from gray to blue or whatever, and it becomes underlined. But neither of these things actually affect the layout of the page. Like, nothing shifts around, nothing changes size or whatever. So the hover effect on GitHub, and indeed on most of the web, is strictly a visual change with no layout change, just a paint change. But we don't know that. So what I was thinking today is that in order to get rid of this situation where we have to rebuild a new layout tree because style changed, we would somehow know that if you only changed like a color property or text decoration like underline, or any other property that does not produce a layout change, then we would avoid doing a relayout. So yeah, it would be pretty cool if we could get rid of 35% of all the work that's happening when I'm doing this. So let's get started on that. And my idea for this is that it would be really cool. We have this thing called properties.json, and this is essentially our input to the build system that contains information about all the different CSS properties that we support. And I was thinking, wouldn't it be sweet if you could just annotate properties here, and you could say things like, I don't know, like background color right here, like affects layout, false, because changing the background color of an element cannot affect the layout. And then we could just, we should go through this and make sure that we do it correctly for everything that can't affect layout. But I'm just going to do some of the basic stuff. So like color, and what was the text decoration line, presumably. Text decoration line. Yeah, that's the underline thing. I think those are the main things that are changing here. There might be other stuff that changes as well. We'll figure that out. But just to get started, I've marked those properties as not affecting layout, and then we will just default. If you don't specify it, we'll assume it affects layout. And then from this JSON, we have this code that runs to generate property id.h, which is a generated file that we have. And let me see if I can find it, name property id.h. Yes, right here. And it has a handful of enums and also some helper functions that allow you to ask questions about our property IDs. So what I was thinking is that we would make something like this. Property affects layout. Okay. And then we also have to generate the corresponding C++ for that. So where does that go? I guess somewhere near the bottom. Bool, property affects layout. CSS property ID, property ID. And here we have to spit out some code. So I'm just going to grab this code right here that sort of walks the list of properties that we've already slurped up earlier in the program. So iterating all the properties we have from the JSON, we check if we have an affects layout property. Let's see, can we do a get affects layout value or true, maybe? Something like that. Affects layout is this. And then, wait. Let me just use one that already has a switch, actually. Yeah, I'm gonna use one that already has a switch. We have is inherited property. Yeah, let me just copy paste that one. Then I don't have to. It's a little bit hard, I think, to work with this code that has like you're generating C++, and it breaks my brain a little bit sometimes to write code that writes code, if you know what I mean. Let's see. So how does that end? Nope. Dang it. Okay, wait, let me start over. I'll just put it right up there so I don't have to deal with the namespace ending. Is inherited. Okay, I'll put it right below that guy. Why am I struggling with that? It's like my brain is breaking in real time. What am I trying to do? I just want to copy this whole thing. This whole thing. All right, there we go. That was too tricky. Property affects layout. Let's say, yeah. That's what I want to do. Okay, so get inherited value or true. And then if it's affects layout, then we will generate something like this that says return true for that guy. Otherwise, we will say return false. That's probably fine. Right. We could even do this for extra fancy output. Okay, let's see if that can actually build. Nope, we messed something up. All right, hold on. Get effects layout. And what does it return? It returns a JSON value. Oops. Okay, so JSON value to a bool. Oh wait, it doesn't have that API. I'm mistaking it for a hash map. All right, so bool effects layout is true. And then if value as object has effects layout. Yeah, this does not need to be fast in any way because it runs as part of the build system. It's not used at runtime. So I really don't mind having like random inefficiencies in this code, as long as it doesn't take like obnoxiously long to generate the code, of course, but not really the place for micro optimizations. Or not the place to worry about it, at least. So now, presumably we generated that thing. So let's take a look at what came out. Oh wait, it will go actually here. Okay. Effects layout. Yep, this is our property effects layout. So it will list all of these things that I didn't mark and say they affect layout, and everything else will be not affecting layout. So that means that text decoration line is missing here, as you can see, as is color. So we'll see how this goes. Now that we have this thing though, we have to actually check, yeah, this is gonna be the tricky part. So now that we know which property changes to ignore, when we recompute style for an element, this is called whenever something happens and we think, oh, well, style may have changed for this element. Maybe the style sheet was updated, maybe some attribute on the element changed, something happened in the document, and we think we need to go and recompute whatever style applies to this element. So what we do here is we ask our friendly style computer to compute the style, and then we have a very simple check here that just checks, are the styles identical? If so, return. So we do not invalidate layout if they are completely identical. But of course, that's not the case here when we're hovering, because the style does change. So I guess mcomputed CSS values is the old CSS values before we assign the new ones to the element. So maybe we'll do something like this. If we have old values, now we want to compare them to the new values, right? So we want to iterate through all of the possible, what do we call this? CSS first property ID, which is an enum. So I guess we should just auto that. Last property ID, inclusive. Okay, property ID is static cast. Okay, so we're going to check every possible property ID. This is a little bit crude, but basically the way computed style works in our engine is that for every element, we figure out the computed CSS value for every possible property. So here, we're just going to go through them, compare them one by one, and if we have something that differs, we have to invalidate the layout. But if it differs, but it's a non-layout affecting property, then we don't have to invalidate. So let's see. We'll say something like needs repaint, false, bool needs relayout, false. And then we will update those as we go. So let's see, property old value is going to be computed CSS values, properties at property ID, no, at I. Okay, oops. And these are ref putters, by the way, so they can be null. And I guess if old value, if either of them are null, let's say, let's consider that a relayout required, because then on the very first time that we are here, we will have null values, I think. So, or we may have null values. So let's just handle that by saying needs, you know what, I'm going to factor this into a separate function because it's getting confusing already. Invalidation required. None. Repaint only. Relayout. Okay, and then invalidation required. It's going to be none. And if we have old values, or no, I guess the default will be relayout. But if we have old values, required invalidation for M computed CSS values and the new computed CSS values. Yeah, this will be easier to reason about as a helper function. Also, let me rename this required invalidation. Compute required invalidation. Old style and new style. Okay. So the old value will grab you right here. Bloop. And the new style. Okay. And if either of them are null, we will return required invalidation relayout, because we have to relayout if something is null. Sure. Okay, otherwise, if old value is not equal to, or if they are equal, actually, I think we can compare them like this. Yes, we can. If they're equal, then we will simply continue. Okay. And if, now we're here, so it means that they are not equal. So if CSS property affects layout for property ID, then, and only then, do we return required invalidation relayout. Otherwise, otherwise we may need to relayout because we have to check the rest of the properties. Otherwise, we are at repaint. Okay, so let's see, requires repaint false. So it becomes true here because we have properties that change, but no relayout is required. And at the very end, if requires repaint, then return required invalidation repaint only. Otherwise, required invalidation? None. Yes, I think that makes sense. Okay, actually we can auto that. And then let's see. So if what exactly? If required invalidation is repaint only, then I think it should be enough that, or repaint only, and we already have a layout node. So we have a layout node, then we can do this. Layout node, apply style, computed values, and tell it to redisplay itself. So set needs display and return. Otherwise, if required invalidation, oh wait, we can do none first actually. Nothing required, return. Yeah, because nothing changed. And if nothing changed, we can also leave the old ones in place. Now that I think about that. Yeah. Yeah, so and then if we're down here, that means that we can verify actually, just to be sure. Required invalidation, relayout. Yeah, so now we have 3 types of invalidation that can occur. No invalidation in response to style change, a repaint only invalidation, or a full relayout invalidation where we have to actually relay out the page. That will be by far the heaviest, so we want to avoid that. Let's see. Okay, and then I guess it would be interesting to print out somewhere that we're doing like a paint only invalidation for something. Repaint only for the element, or if you're changing the style, we'll say like relayout. Just want to see this in action. Oops. So I guess we can just test it on this page right here. All right, so it's saying relayout for everything. It's never just repaint. Okay. So we can probably print out why that's happening. If we have a layout affecting property right here, then we can print out property changed requires relayout. Let's just see what it says. Wait, it doesn't say anything. Oh, okay. Did I not think correctly somewhere here? Let's see. If old value or not new value. So if either of these are null, well, let's print that out. Old value is new value is That should be the relayout case, yeah. both are null. Oh wait, if both are null, then that doesn't matter. Right, if old value and new value, if both are null, then we can just ignore it. So that's going to be the case for various CSS properties that are like either they're shorthands, so we don't care about them because they actually expand into several other properties, or if they're just like properties that we don't actually use in the engine. They're just like unused values. So that should be fine. Okay. I was not thinking about that, but yeah, like it's not going to have an entry for every property ID because some of them are not used in the finalized computed style. Okay, repaint only for A. Very promising, right? So something is changing here and it only demands a repaint. Very, very good information. Okay, so let's see. Actually, let's see if that works on GitHub as well, because now I was just testing it on our very simple welcome page that we have, but presumably it will be just the same on GitHub, just that the DOM is more complex and there's more CSS in effect, but I think the basic idea is sound. That's what I said until I crashed. Required invalidation must be relayout, and it's not. Oh yeah, right, because it could be repaint, but you don't have a layout node yet, so we haven't constructed a layout node. This is first time we're here. So we'll just do repaint only is the only thing that's required. So it is actually fine to fall through there, because if we determine that a repaint is all that's needed, but we don't have a layout node, we're still going to have to layout. We just have to suck it up and do a layout. That's fine. Okay. All right, so can I get those things to show up? Okay, here they are. Okay, relayout because property outline width changes. But outline width should not affect layout. Wait, let me use Firefox. Outline width sets the thickness of the outline, but the outline is painted, not affecting the layout. It's not part of the box model, right? Yeah. Oh, this CSS working group draft server is really random if it's going to work or not when you try to load a draft spec. Anyway, I'm pretty sure that outline width does not affect layout, so I am going to mark it as such. In our new fancy file, and we'll try that again. There might be more properties that they change actually, but I guess this is one way to discover which ones they are. Repaint only. Okay, so this is promising. Good. Relayout has to happen in some cases, apparently. But yeah, we should be able to make this go fast. So let's see, can we just get rid of these debug outputs, and then I want to profile that and see if it actually gets rid of the tree build. That would be really interesting, because it didn't feel like a 35% was gone from the work that was being done, but I don't know, we'll take a look here. Oh, and then you have to maximize it. Okay, that's enough of that. Okay. So, tree builder still here, although now it's at 19.5%. So there's a reduction, but I feel like I was expecting to see it go to 0. So maybe we are still invalidating layout unnecessarily somewhere, like when we update style for the document. We unconditionally say set needs layout. Okay, yeah, so this guy needs to go. Update style recursively. So, right, so here's how this happens. Basically, once we discover that there's an element somewhere in the DOM that needs a style update or style refresh or whatever, we mark it as having dirty style. We set this needs style update bit on the node, and then we schedule a style update, which gets coalesced if you have many things that are changing style. But basically, we set a 0 timer so that the event loop will, on next iteration, will call update style, and then we update style recursively from the root of the tree, from the document, all the way out to all the leaf nodes, and we find anybody who has this bit set and call recompute style on it. And after that, apparently, we say that we need a layout. So I think the obvious improvement here is that recompute style, which we were just working on, needs to just tell us if something was changed or not. Yeah. I guess it can actually pass back the required invalidation. So maybe this should go in element instead. Recompute style, required invalidation. Oh, what's a good name for this enum? Like consequence of, no, required invalidation after style update. Something like that. It's very, it's a mouthful, but it also tells us after recomputing style, or after style update. After style update is pretty good. Okay. There we go. It's a mouthful, but we'll know what it is. That's valuable. Okay. Return required invalidation. Oh, actually, in this case right here, we have to return, we can't return required invalidation, we have to return requires layout. Because required invalidation at this point is actually, it may be repaint only, but if we didn't have a layout node, we still have to relayout. Yeah, so let's be explicit in what we return. There we go. Okay, and then document, I suppose can use this thing as well. Okay, let me go ahead and start a rebuild because there's going to be a bunch of files involved here. Required. Required invalidation. None, let's say. Okay, if required invalidation is wait, this becomes very, I think maybe okay, wait, this is not becoming very readable. Let's back up, because I'm realizing now that all I care about here is do I need to do a style update afterwards? Because the element has, if in a repaint is needed, then the element has already taken care of all that stuff. So what we really want to return is whether or not a relayout is required, which we can do with a Boolean, honestly, and it makes the logic a bit simpler. Let's see, returns whether a relayout. Okay, I already hate that comment. Enum class needs relayout. Yes, 1, no, 0. Yeah, something like that. Oh man, and then I broke the enum that I was using for the other thing. So let's get that back to where it was when it was just living in this file right there. That was great. But instead we want to return this special element thing. Needs relayout. Yeah. Needs relayout. No. Needs relayout. No. Needs relayout. Oh yes. Yes, it does. And I suppose, wait, I guess it's okay for this to be here, although maybe it shouldn't be. Invalidate layout. We can do that further up the road, because this is only ever called by the root style update mechanism anyway, so we don't have to invalidate the full document layout here. So this guy should return an element needs relayout, or just a bool at this point. If this guy returns element needs relayout, yes. Okay, here we go. Yeah, so if anybody in the whole style update returns needs relayout yes, then this function will return true, which means that we need to do a layout. Maybe even we'll do a full relayout. We invalidate the existing layout and just start over. That's fine. And wait, is that everything that we need? Okay, what happens if we do that? Yeah, it's tempting to make it return one of these things. It feels weird that it's like part of element. Needs relayout. Should I liberate it and make it a top level enum? I guess it's not the most important thing in the universe, but it's annoying here because I like the convenience of having the or assignment thingy, but if I use the enum, then I lose that, and suddenly this becomes much clunkier. Or here, actually, I can just assign to it like this, but further down, it gets a little trickier because I would have to do descendants need relayout is this, and then I guess if needs relayout is equal to element needs relayout no, then needs relayout is whether or not the descendants need it. But this just became so much harder to read, so I don't like it. Maybe there's a much more straightforward way of writing that, but I'm drawing a blank right now. So I'm just going to stick with the bool just to make it readable. But I feel like over here in element, it makes sense to use the enum because this is sort of an API of element. Whereas here, this is just a helper function within the document CPP file. So this guy is only used by update style. So it's like really just a helper for update style. It's separated so that it can call itself recursively. All right. Does this work? Well, at least the hover effects were working. Let's see. Oh, well, failed to load. Let's try again. Sometimes we don't handle DNS failure gracefully. So like if you get a fail to load because of DNS resolution failure, you just have to restart the browser. It's kind of dumb, but it is what it is. And now what happened? Oh. Wait, what? Okay. I mean, it works, but I'm not sure if it's faster or what. So let's do what we like to do and just profile a little bit. Okay. And the main thing we're looking for is just, did the layout tree builder code disappear, which was previously allowed. It started at 35%, then got it down to 20 or whatever. And where is it now? It's not here, which is fantastic. So web layout tree. There is no tree builder. That's awesome. Okay, so we have gotten rid of the tree build step, but it's still not super fast. It's definitely faster, like noticeably, but it's not like instant. So I think we should push this further. Let's see. The HTML spec is usually pretty heavy. Yeah, look at these. These are very laggy. And I bet you that we can do better here as well. Oh, wait, shoot. I forgot to prune the old profile. Okay, there we go. I think it's essentially the same as we're looking at on GitHub, just even heavier. Yeah, like 70% of hovering is just update style, doing all this style recomputation. Very, very heavy. Of course, when you have a DOM that's just huge with lots and lots of stuff, lots of elements, you have to compute style for each one of them. It's going to take time. I do feel, though, that I've introduced some kind of missing invalidation bug here, because when I opened GitHub, it didn't actually show the styled version of the page until I resized it. Yeah, we're just seeing this one. So there's like a missing invalidation somewhere. Probably that was taken care of before by the document invalidate layout here. Let's see if that fixes it. If so, I was going to say fix me. Get rid of this layout invalidation and let document take care of it. Let's just verify that that actually was making that work. Yeah. Okay. There seems to be some missing invalidations somewhere else that this is papering over. Yeah. Okay. So this is very, very cool. So let's see, what can we do? Another thing that we should really consider at this point, now that it's no longer the case that style changes necessarily invalidate the layout, right? So now we're not going to eat the cost of a layout whenever you touch the mouse over the page. So maybe we can also reduce the amount of invalidation that occurs. And specifically when we're hovering and hover node, set hovered node, this guy right here, it's a document level API, and it will currently invalidate style for the entire document. So this is very aggressive. And we talked a bit on the browser channel on Discord, I think yesterday, about ways to reduce invalidation here. And one way that we can do that is to figure out, like, when you're moving hover from one DOM node to another, try to find the common ancestor between those two nodes and only invalidate the common ancestor and everything below that. So let me show you what I mean. Ninja rune. On this page right here, for example, if I am hovering over these different links here, they are, let's see how it looks at the HTML. Yeah, so it looks like this, right? They're li tags with anchors inside of them with some text. And when I move the mouse between these guys, I'm moving between these different A anchors, and the common ancestor that they all have is the UL element, right? So I think it should be enough to invalidate this guy and all of his descendants. It's still a large invalidation, but it's substantially less than what we do currently, which is to just go up to the root and invalidate literally the whole document. So let's try to do that. And we will do that. How do we do that? I guess we want to find a common ancestor. So common ancestor is find the common ancestor for two nodes. So like M or old hovered node and New hovered node. Okay. If we have a common ancestor, then just invalidate style there. Otherwise, invalidate style in the whole document. Okay. And then how do we find a common ancestor? We will write a function to do that, I guess. Find common ancestor. Okay, node A, node B. Okay, so if they are the same, then the common ancestor is A, I guess, whatever. Then if you're somehow moving the hover from one element to itself, then we should have already failed out here, but let's just write this in a generic way so that we'd return true for that. Otherwise, what do we want to do? I guess we want to collect all the ancestors for one of them and then walk the ancestors of the other one and figure out if it's in the collected set of ancestors. So something like ancestors of A ancestor. Oh wait, if either of these are null, A or B return null putter. Yeah. Something like that. If somebody's null, then they don't have a common ancestor, obviously. Okay, so parent or shadow host, ancestor is ancestor parent or shadow host, and then we will collect these. Okay. And then we will walk the ancestors of B. Oh wait, am I thinking of this right? What if A is an ancestor of B already? Yes, I have to start at A actually. Okay, so let's see, let's just call this node. Let's call this ancestors. I feel like I've written this function at some point in the past, but I don't remember where it is. Did I not write this somewhere? Common ancestor. Common ancestor. Container. Did I write this code? I did. Wait, while container is not an inclusive ancestor of it, no. That's probably a more efficient way of writing that. Okay, anyway. That's not exactly the same as what I want to do here. So let's see. We'll start at B, and then while node is node parent or shadow host. And then if ancestors contains node, then return node, because that is the common ancestor. Yeah, so A could be an ancestor of B. That's fine, because we put it into the set. Okay. Invalidate style at common ancestor. Otherwise, debug line, invalidate entire document. Oops. Wait, I closed my terminal. This is so much fun. Like, I'm just disappearing into the zone of, of browser performance work here. I used to do this every day in the past, and it's definitely something I really enjoy. So getting to do it here again, and now at like increasing levels of sophistication in the Serenity OS browser, it's a real treat, I gotta say. Oh man, now I just went to GitHub straight away. I wanted to test it on our local page first, but I guess we can test it here. Can I get a scrolly? We are invalidating common ancestors. Oh, and look at how fast that is. It's actually responsive. Holy moly. That's so cool. All right. Okay, let's see that local page here. Validate. Yeah, right. So see, now it's only invalidating at whatever the common ancestor is. Very, very tight. And what about the HTML spec that we were checking on before? What does he say? Common ancestor OL, and look how fast it is. That's so nice. God dang. Man, that's so cool. I love it. That's so awesome. This is way better than I thought we were gonna do today. Really pleasant result. But wait, did you hang? Or no? This page is not reacting to my mouse events anymore for some reason. But it's not burning the CPU either? I don't know what's going on here. That was weird. But it didn't log one or the other, so I'm going to assume that we were not even in here. This is so cool. Okay, I gotta get rid of the all the printing, and then we can actually profile this and see what remains now that we have substantially reduced the amount of invalidation that occurs. Because now, basically, when the stuff that we invalidate, that's the stuff that we have to recompute style for. So previously, when you hovered something, we would invalidate the entire document. So every single element we had to recompute style for. So we had to rerun all the selectors, find all of the CSS properties and so on. And now we're doing that for a substantially smaller set of elements, right? So let's get a profile of this on GitHub. Sometimes it's not reacting to the mouse wheel. That's a bit weird. I think that's totally unrelated to this. Just something that needs to be investigated at some point. Oh man, look at it go. See, it's not even hitting 100% CPU anymore while we're doing this. How cool is that? Okay, so what's going on here? We have update style at a measly 33%. And let's see, it's coming from, painting. Painting is now dominating instead with painting is 28% in the actual painting and 2.5% in updating the layout, which probably just updates style. Yeah, exactly. So suddenly painting becomes the new performance problem when hovering over the page. And that's awesome. We've basically shifted the performance problem from one subsystem of the browser to a completely different subsystem. That's great news. Yeah, so as you can see, of course, we still use the CPU, but that is now very, very painty. So an area to improve in the future. Let's see. Well, to be fair, we still have 24% in rule matching as well, but to see painting so high, that's really, really cool. I guess that's sort of what happens when the browser becomes more responsive, then we paint more often because our FPS increases, right? So now we can actually paint all of these hover transitions. So we end up doing more work on that. I'm just just enjoying the moment. This is so snappy. Oh man. Okay. Anyway, let's make some commits here. So starting with the property effects layout thingy. So I didn't mark very many properties, so we're gonna have to mark more of these, but I will just add the mechanism here. Libweb add annotate. Annotate which CSS properties can may affect layout. This patch adds CSS property affects layout property ID, which returns, which tells us whether a CSS property would affect layout if it were changed. This will be used to avoid unnecessary relayout work when something changes that really only requires us to repaint the page. To mark a property as not affecting layout, add set affect layout to false in the corresponding properties JSON entry. Note that all properties affect layout by default, so this is yeah, we'll just say that. And then let's see. So now we're going to do the whole mechanism where we actually only invalidate for repaint if only these properties changed. Yes. Okay, so don't invalidate layout when only when no layout affecting properties. Wait, let's see. Avoid invalidation. Avoid layout invalidation for some CSS property changes. Use the new CSS property affects layout helper to figure out if we actually need to perform a full relayout after recomputing style for after recomputing style, yeah. There are 3 tiers of required invalidation after an element receives new style. None, repaint only, or full relayout. Yeah, this avoids a lot of work. This avoids rebuilding a lot of work when doing basic. It avoids a lot of work in general, I guess. This avoids the need to rebuild the layout tree and perform layout on it when can we call them trivial properties? I guess like trivial properties like color, etc. are changed. Let's see, that's pretty good. Yeah, that's already pretty good. And then let's add that thing here as well, where we only invalidate the common ancestor if they have one. Yeah. Only invalidate less style when switching hovered node. Moving between hovered nodes. Instead of invalidating style for the entire DOM, the entire document, we now locate the nearest common ancestor between the old and new hovered node, old and new innermost hovered node, and only invalidate that ancestor and its descendants. This drastically reduces the amount of style update work when mousing around on GitHub and any other pages, really. It's actually really, really snappy now. Very cool. Yes, that's so cool. I am just very, very happy with this progress. I gotta look at it some more. Let's look at the HTML spec, because this document is just such a monster. And look at it go. Man. I'm so curious what's going to be like the next thing that we want to do here. I mean, there's obviously like we can still make selectors substantially faster and run fewer of them and stuff like that. But it's kind of exciting to look into paint optimization, see what we can do with that. Actually, let's look at the inverted tree. Oh, establishes stacking context is heavy. Wait, what? Why is that even a thing? That we could probably just make go away. UTF-8 iteration. Line wrapping. There are lots of little things. So interesting. A new unoptimized space to look into. How exciting. Anyway, let me not get carried away with that now, because I think we're going to end the video here. So I'm really, really pleased with the result. Yeah, let's end it here. If you made it this far, then I thank you for watching and for hanging out. I hope that you saw something interesting here today. And for the 50th time, I really, really enjoyed this, and I'm really pleased with the results. This is super duper cool, and I gotta see it one more time. But there's a bit of a stutter when this page loads. Like, by stutter, I mean it takes a second or two. Hello. But once it's ready, yeah. Wait, now it's dead. What happened here? Okay, this is gonna need more investigation. I don't know what's going on with this page. Anyway, I am super pleased with the result today. We have become a lot faster at a very common thing, so that's awesome. Thank you so much for watching, and I will see you all next time. Bye.